Hey everyone, this is Abdul Sami, your AI engineer, and this is the second video of LLM series in which I'm going to explain you the concept of metrics. Okay, so if you really want to become an AI engineer and if you are really new to that field, this video will be really important for you to understand what actually the matrix is. Okay, in our real world, okay, in the world where we are living. Okay, so there are like three, maybe four types of classes, like upper class, lower class, middle class, higher class, okay, or maybe elite class, you can consider. So how we are going to, categorize these classes? Maybe there are a couple of questions comes in our mind. Maybe if the person has maybe a millions of dollar in their bank account, he is maybe a elite class, and a person has a thousands of dollars, he is like middle class or lower class. Okay, how we, like, maybe there are a couple of questions. The person has a Bugatti, okay, and he is belong to a elite class. Okay, so there are, there may be a little more question comes into your mind, and then you decided, okay, no, this person belong to this class. Okay, so same goes here. In the matrices, like dimension means number of questions. Okay, for the easiness, I'm going to tell you. Dimension means a number of features. And on the basis of those questions and those features, in that space, the one vector is representing a one value. Okay, so let's suppose here is a space and I made it like 0, 1, 1, 0. And this is a two dimension, very simple example, very simple example. And space is for rich and poor categories, only two categories. Rich categories is 0, 1, we are representing, and poor category we are going to represent 1 and 0. Okay, and we have no two questions. Okay, on the basis of answer, we can see the person is rich or poor. So first question is your business ROI is more than 10%, like business ROI. So maybe person is doing a business. So for the person one, it says 0.5, mean like, yeah, 50% I can say, yeah, my business ROI more than 10%, but 50%, it like there is not 100% sure like 10%. It might be 8, 5% or 6%. So that's why I put 0.5. Okay. The second question, are you employed? So I put 0.3 because of course if the person is RO business ROI 0.3%, 0.5%, it might be person is not employed. He is doing some business, maybe a startup. So that's why, yeah, it's not employed, but he's also not a businessman. He's some a middle category. So I said, yeah, 0.3. So the person has some this value person one. Same now goes to a person two. Is your business ROI more than 10%? I put a value 0.2. Like maybe the person, a business ROI is only 2%. Maybe he is doing freelancing, some side business where a very little ROI. And are you employed? And of course, the business ROI is very low. So we consider this, okay, maybe person is employed somewhere. So we can consider 0.8, 80% chance person is employed. Same goes up person 3. So business ROI is like 0.4 and I put 0.6. Okay. Okay, just consider this. And then using a matrix multiplication with this space values. No, our space is 0, 1 and 1, 0 because 0, 1 and 1, 0, 0, 1 for rich and 1, 0 for poor categories. And when I'm going to multiply these vectors with this space values, you consider because let's suppose. Okay, I will explain you this part later again. Okay, now consider this. I'm going to multiply these vectors values with this space. So at the end, what I'm going to get? Now you see in this matrix, there are now three people. Okay, so I read is about the person one. Okay, so person one, according to the answer, is more richer than all of them. So that's why you can see it's lying on here in the space on the top. Okay, 0, 1, 0. What about the like 0, 1? Okay, 0, 1 is a rich category. Okay, so 0 is the row, 1 is the column. So the person 1 is more into the rich category according to these values, what we represent there. Person 2 is 0.2 or 0.8. It might be very more into the poor category, is blue. So you can see blue is here. It's more into the poor category. So same goes for person 3. When I multiply with this space, so it's like maybe a middleman, like sorry, the person 3, 0.4, 0.6 value. It's totally a middleman. So that's why it's lying here. So now you understand because when you see these three vectors values, maybe it does not make any sense. Okay, but when we multiply with this space, so according to those space values, these vectors are going to represent some meaning in that specific space. Okay, so let me give you a more good example so you have a better idea what actually I'm trying to say. Okay, so here you can see. Category classification space explanation. Let me give it to you. Question that define the space. What percentages of your income do you save monthly? 0 to 100%. And how many hours per week do you work? 0 to 40 hours normalize. Okay. So on the basis of that, now we are going to categorize the percentage rich or poor. Previously, it was a very basic example. Now this will, it will make you more clear idea about what I'm trying to explain the concept of space, vector, and the basic space is actually is a matrix, and that's why I say transformation of space, and how space is going to be transformed when you see those matrix values. Let me tell you. Category vector, answer to question, rich category, 0.9, 0.2. What is the meaning of this? Like 0.9 means if the first value is 0.9, that's mean the person saved 90% of the income, and the 8 hours per week, the person is working 8 hours per week. Of course, this is the rich category. The person who is only working 8 hours per week and saving a 90% of income, that's belong to a rich category. Second person is the poor category, whose value is 0.1 and 0.8. That's mean person saves 10% of the income and only work 32 hours per week. Okay, same for the middle class, save the 50% of the income, work 20 hours per week, and hard-working rich category who saves 70% income but work 24 hours per week. Okay, so here, let me tell you one thing. So in the space, there are space has two dimensions, each dimension representing one value, and according to that value, when we are putting these vectors, when we are multiplying one vector with a matrix, we call a matrix multiplication. Okay, at the end, in the response, okay, what we will get, that vector representing some meaning in the space, and that meaning tell us, okay, this vector is rich in this space and this vector is poor in this space. Okay, this is how the even model understand when we are putting a word, and when model give me embeddings, and when we put that embedding to a model, so model on the basis of the embeddings, model understand, okay, this is what that word is representing a meaning in the space. Okay, okay, let's go economic after economic transformation. Okay, now this is very twist part. Previously, what I mentioned to you, we in the space we have two dimensions. One is 0, 1, and second is 1, 0. That means that's the identity matrix, which means there is nothing happen in space. There is no transformation. But let's suppose there might be some economic transformation, and after the economic transformation, rich category becomes 0.78 and 0.5. That means the person who is going to save now 78% of the income and 20 hours of hard work, that person belong to a rich category. How actually this will work? Let me tell you, show you something here. Okay, now here you maybe if you are not clear what I'm speaking with you guys, now here everything will be more clear to you. Okay. So here this is a simple space. You see this is a zero value, this is a one. 0, 1, this is the rich this is the sorry poor category here because when I was working, so I made it poor. And 0, 1. Like from 0 to 1, this is the rich category, and this is from 1 to 0, this is the poor category. Okay, so you can see in here 0 to 1, this question is what percentage of your income do you save monthly. So this dimension which is here, this dimension is representing how many income I'm going to save. And the second, this dimension who is going up, because this is a 2 matrix, and when there's a 3D matrix, it might be some dimension comes here at the bottom, maybe like this. If there is 4 dimension, maybe something like this, maybe this 5 dimension, so 1, 2, 3, like there are multiple dimension in the space. Okay, so let's go, there are only 2 dimensions, and each dimension has one question: what percentage of your income do you save? Now you see, whenever the percentage of income is growing and number of hours is decreasing, so person is more rich. And when the number of hours is increasing and percentage is going, the person is hard work. But when the number of hours is decreasing and the percent in the income is less, more less, so that belongs to middle class. And when saving income is very less, but again the hour is increasing, the person belong to poor category. And at this point, this matrix is identity matrix. Nothing happened in the space. But in the second, when there is economic crisis, something happened. Okay, so what economic crisis mean? Okay, so here you can see this is the space. This is a zero value, this is the one, and this is a zero, and this is the one. This means, and this space Nothing happened. Nothing happened. Maybe the one vector is here. Okay. But let's suppose I'm going to change the space value now, because maybe the vector has some different values. Maybe this vector value is something like 0 and 0.5, something like this, 0.5 and 0.4, something value this, that's why it's here. Okay. But now I'm going to change these 0 and 1 value, like I'm going to change the space values, and it might be something like this now. So here it's not 0, it might be like 0.3 to, let's put 1, and 0.3 to 0.7. Some economical crisis, I changed some of the values. This is somehow the transformation in the space. And when the transformation in the space, no, this vector maybe comes here. Because of course this vector, previously the vector values, this vector value was 0.2 and 0.4. But when the space will be transformed, the vector value is still there, but the position will be the change. You got my point? Because no space is transformed, no, the space is changed. When this space is changed, because no, this is the identity matrix, like nothing happened in the space. But when the space is changed, even the vector value is still same, but the position will be different. Okay, now let me tell you here. Now see here, because I changed the space value. You see, now the space transfer, now the space transformation matrix was 0.8 and 0.3 and 0.4 and 0.7. Previously, it was 0 and 1 for the rich category. Here, 0 and 1, and 1 0 for the poor category. Now, it's not 0 and 1, it's 0.8 and 0.3 for the rich category. Okay, so that's why when I change these twists, these vector values are the same, but when the space is changed, so that the vectors now are lying in the space in a very different direction. Okay, now you need to understand a concept how a model is going to train. The word embedding models are trained. By default, you have to assume model has some identity matrix, like nothing happens in space. Basically, we are initializing some random values, but for your information, model has some random initialization of weights. But when you are training a data, let's suppose we put some English tests like I love pizza, you love to doing parties, like whatever. There are multiple sentences. We are going to train it. Embedding model is something like a space. Think like a model brain in the space, and the word has some vectors. Okay, now model is going to train themselves, updating their weights, changing the transformation of space in that way, and then each vector is going to lie in that specific direction. Don't think like this is something like simple vectors. These vectors mean this vector is basically a world. Okay, and this space is basically a model brain. Okay, and this word is going to represent some meaning in the model brain. And when we are going to write some text and inject in the model, and then model give us some embedding vectors, that's mean that word is representing somewhere in the model, which model simple get it and give it to you. Okay, this word has this thing, like this meaning for you. Okay, so this is concept here. Let me give you another example. Okay, second example is about the, let's suppose no model has three dimensions. Now the space has three dimensions. The first dimension is how royal is this entity. What, and we are going to direct the king, queen, man, woman, knight. Okay, like in this space, no model has to know. Okay, in this space, who which vector is the king, which person is the queen, which person is the man, which is a woman, which is a knight, and which is the maid. Now this is the model job. So how model will learn it? So how royal is this entity? Now we have three questions. What level of authority does this entity have? Gender spectrum, feminine, like positive. Okay. So word vectors, king, 0.9, royalty. If someone has 0.9 royalty with 0.8 authority and gender is 0.7, that means that person is a king. Same goes here. If the royalty is 0.9, authority is 0.8, same like a king, but now the gender is opposite, like minus 0.7, because this vector is somewhere opposite to the king. So that's why it will be a queen. Same goes for a man, because man royalty is a little bit less than the king, of course, 0.2, but authority is also a little bit less than 0.5 because he is not a king, but gender is same like this king. So that's why it will be a man. We just reduce some royalty and authority. Now the person become a man. It's not, he is not a king, because we just, snatch something. This is how the concept of matrix works. There's nothing something special. It's same like how the real world things working here. Okay, guys. Same goes for the woman. Same these values, but I change this value to negative. No, it's opposite in the direction in the matrix. Okay, no, it's representing some different meaning. That means this is what its woman is. Same goes for the night. Night is the gender is 0.5, but the it has some royalty, but also it has some less authority than the man. So it's a night. Same goes for the mid here. Okay, same values but with opposite direction. Okay, let me show you now the visualization of man, king, knight, queen, woman, and maid for these things. Now you see there are three things. How royalty is this entity, what level of authority this entity have, and gender spectrum. And now you see man is lying here, and this is a basic identity matrix when nothing happen in the space. And this is a man which is lying here, position here, and the opposite side you can see there will be a woman here. But king and knight are very similar. You have to understand one thing. These three still have in the same space, and these three is opposite. So model can easily understand. Okay, which understand and identify the meaning. So when our we are going to train a model, so model with the help of these things, no model easily understand. Okay, this man has this meaning. So when we say man, king, how the AI model understood like difference between king and queen, man and woman, just because accordingly in the model brain, so these values are representing in that way. So it's really easy for the model to understand. Okay, this is a king and this is a knight. Okay, so for the opposite gender, I need to simply go opposite and see. Okay, here is a queen and here is a maid. Got my point? But somehow when there is a transformation in the space, okay, let's suppose now I transform a space from 0.9, 0.10, 0.2, 0.7. Like I transform some values. Even the vector values are the same, just the position is now changed. Now the man values goes here, the king goes here. You see a little bit at this thing I explained to you previously as well. And you need to understand one point. The man is not going to come here after transformation. Of course, it will never ever come to close to a man. You see, this thing you need to understand. Okay, each value represent will be the same as previously. Even the space will be transformed. Okay, whole thing will be transformed. Nothing will close to the man and man goes to a woman. No, these things stay there. Okay, just change the position everyone accordingly how the matrix will be transformed. So here is the last example of this concept, okay, and this is the core concept of what I have explained in the whole video, okay. So this is the example of transformation of one word called bank, okay. As I mentioned to you, each word has some vectors, and each vector representing some different meaning in different spaces. Even the word is the same, but each word represent different meaning in different spaces. Let me give you example. Here, the sentence is the bank is by the river. It apply a transformation matrix to a word bank that emphasize the geographical meaning, because when we multiply this here bank with the geographical of space, it represent a different meaning in this sentence. Okay, but if I write a such sentence, I need to bank my money. You can see the bank and bank, the words are the same, but here the bank representing a different meaning just because of this sentence, just because of this space, because here this is the geographical space, and here the word representing a different meaning just because here is the transform is the financial space. Okay, so this is how the AI model works. This is how the AI model, the brain thinks. Like whenever we are writing a word, and when we are writing a word, so when word multiply with the different space, so each word representing a different meaning in the different space. Okay, so this is how actually the things work. Let me give you a brief idea here at the end how actually it will happen. So the bank context explanation, the first question is like, no, we have 3 by 3 matrix. So first question is this related to the finance? Is this related to geography? And is this is a physical object? Okay, so now we have 3 questions. And according to this question, model knows, okay, no, this bank is representing where in the space. So base bank, so this is the base bank vector. So default vector value 0 0.5, 0 0.5, and 0. But in this is a financial context. That's mean, context is depend upon the sentence. So that is basically financial context mean financial space. Okay. So space is the meaning of the context. So in this financial context, the values are 0 0.5, 0 0.15, and 0 for this financial context. So for geographical context, the values are 0 0.1, 0 0.85, and 0. So after multiplying, how it is it look like? So let me tell you example. Here you can see, not this. Okay, so this is where when there is nothing happen in the space. So now you can see This is the bank base. Okay, so when we multiply with the financial, so this bank vector move toward here, so it move the position and it lies here. And there will be a third vector when we multiply with the geographical meaning, so it move to lie here. So there is only one word bank, but in this space it representing a three different directions. Just because when we multiply a word with in different contexts, okay, so that's mean when we are writing a question to AI, so according to that context, AI will think, okay, no, I have to pick this bank value when there is a financial question, but when there is a geographical question, AI will pick that value. So this is how this whole vector concept work within the matrix. So same context here. Now let's suppose I apply some transformation. I change some financial matrix value, and I also change some geographical context value. I apply some transformation, but still you can see here after the transformation they change the positions. They change their position, but still they are like representing the same meaning in the space. Okay, because as I mentioned to you, whenever we are transforming a space, even the vector value is still same, but when the space is transformed, whole vector value position and directions are transformed in the way. So this was the whole concept of the matrices, how actually AI models are trained on the matrix, how the things are working in the matrix world. I hope you understood this whole concept of matrix. But still, if you have any question, please write in the comment, so I will answer you that question in the next video. Thank you so much for your work. Thank you so much for the watching. So see you in the next video. Bye bye.